So in today's session, I will take you through the basics of what predictive analytics is, what prescriptive analytics is, and there are four types of analytics ways in which you can actually apply these. I'm going to take you through those, and also we'll look at a couple of examples, and I'm going to tell you what regression analysis is, time series analysis, and forecasting techniques, and how these are actually used in real-time examples here. So when I talk about predictive analytics or and prescriptive analytics, I'm not just no, I'm not just limiting my analysis for these two. So there are actually four types of analytics which happens in real world. So you have your descriptive analytics, you have your diagnostic analytics, predictive analytics, and your prescriptive analytics. So the difference between all these four is very simple. Basically, what descriptive analytics is, it tells you what has actually happened previously. That is what has already happened. And so you look at the data, you go through it, you clean the data, you transform the data, you make it ready for visualizations, and then you create your graphs, your charts, and even your dashboards. So this is what descriptive analytics is. But coming to your diagnostic analysis, it actually tells you why something happened in the past. So see, when you talk about a descriptive analytics, you are just looking at what has happened. So this would be your question, what has happened. When you talk about your diagnostic analysis, you actually get into the RCA part of it. So what I mean by RCA is root cause analysis. That is, you dig deep into the data, you deep dive, you do data mining, you drill down, and then you actually understand why certain things or certain metrics have gone down or gone up, or you want to discover the trend or things like that. And coming to predictive analytics is the word itself tells. So when you talk about predictive, it is going to tell you of what is most likely to happen in the future. So examples for your predictive analytics is nothing but your all your predictive models, all your machine learning algorithms, wherein you have your test data, you have your control data. So you train your model with your historical data, and then you can see if your model can actually predict the same outcome for your future as well. And now coming to prescriptive analytics, it actually actions. Oh, okay, I think my Wi-Fi restarted once again. Sorry. Just give me 1 minute, please. So coming to prescriptive analytics, along with here, what happens is along with prediction, this system also recommends actions that you can take to in order to come up with your desirable outcomes. So these were the four types of analytics here. Okay, I think as I was talking, so there are a couple of analysis that actually falls into predictive analysis, which is called as you have your regression analysis, you have your time series analysis, you do your forecasting using time series. Now getting into what regression actually means. So regression analysis actually helps in predicting a variable on the basis of one or more other different variables. So here you actually have two things here. You have your dependent variable and you also have your independent variable. So independent variables are also called as predictors over here. So, just to give you an example, so the example that I've put up here. So, what do you think are the factors that actually influence the salary of people? So, there can be many things that actually define your salary. It can be your highest education, it can be your tenure. So, by tenurity, I mean the experience of a person. What type of field is the person into, or what is his or her age? So, all these factors that you see, your education, tenure, type of field, or your age, all these fall under your dependent variables. So all these are your dependent variables. And what are we trying to predict? So here we are trying to predict the salary of a person. So your salary would become your independent variable here. So also along with this, you can also with predicting, you can also measure the influence of all these variables, of all these one or more variables on the variable that you are actually trying to predict. So example, you can also take up this example that I put up. Does parents' educational level affect their children's future educational attainment? There are also a couple of other examples here. Let me move forward. So under regression analysis, actually, you can do two things here. So number one, you can actually measure the influence of one or more variables, the same example that I put up previously. And along with this, you can also predict a variable I mean, you can actually look at prediction of a variable by one or more other variables. So over here, for example, the example that I put up here is how long does a patient stay in the hospital? So for this, you can actually look at what is the age of the patient, what is the illness of the patient, what is the nature of illness of this patient, how many patients have already been admitted in the hospital, what is the availability of facilities, availability of beds. So all these would become your dependent variables. So going forward. Now, again, regression analysis is broken down into three types. So you have your simple linear regression, your multiple linear regression, and then comes your regression. So simple linear and multiple, they're fairly one and the same, but only thing is that the number of variables involved is where the difference actually comes in. So when you talk about a simple linear regression, you take just one variable to actually predict another dependent variable. When it comes to multiple linear regression, here you are looking at one or more number of variables, okay, that are collectively taken up as a group to predict a given variable here. And when it comes to your logistic regression, here it's slightly different because here you are along with prediction, one thing that you are also going to answer here is your categorical data. So what I mean by categorical data is I'll give you with examples. Maybe then it'll become easier for understanding. So maybe here you are trying to answer maybe your yes or no questions, or maybe you're trying to group your data into multiple categories. So things like that. I'll take you through a couple of examples that I put up here. I mean, it'll become easier for understanding as well. So when you talk about simple linear regression, so one simple example that I put here is, does the weekly working time have an influence on the hourly wage of the employees? So here your weekly working time becomes an independent variable and your hourly wage becomes a dependent variable. I mean, you're trying to figure out the hourly wage based on the weekly working time. Now coming to multiple linear regressions, so here along with along with weekly working time, you also have another field called the age of employees. So you are taking both your weekly working time and the age of employees collectively to actually predict what is the hourly age here, hourly wage for any given employee. And now coming to logistic regression. So here, along with that, what you will try to do is you are going to, like I said, you are going to answer maybe yes or no or categorical data sort of questions here. So one example here is, does the weekly working time and the age of employees have an influence on the probability that they are at risk of burnout? Here you will be actually answering a question. So the question here is the depends on the probability of the risk of a burnout. So you will answer whether the employee falls under this risk or does not fall under this risk. So that is where your logistic regression comes up. Now, coming to your time series analysis and forecasting. So, actually, what happens across time series analysis is, so here you do not have just one single data point or a couple of data points, but here you actually look at multiple data points that are actually collected over a period of time. So now, this time period that you take in order to collect these data points is very, very important because it actually depends upon the type of business case statement that you are actually looking at, and it becomes very useful in identifying patterns or any trends or seasonal fluctuations in order to make forecasts or any predictions as such. Now, a couple of examples that I have put here is maybe predicting the monthly sales of a retail store based on historical data. Now, time series analysis. So now when you talk about data points collected over time, this becomes really important in identifying patterns because, this sort of analysis is used in your so many other areas such as your inventory planning, your demand and supply. So just to give you a small example, let's say you work in supply chain. So you are very much involved in inventory planning. So what is the, the products that go into your warehouse? What are the products that come into your warehouse? Do you have enough space to store all your products there? What is the average shelf life that these products can actually be stored? What is the demand and supply for these? And so many other things. And you'll also be looking at a couple of other things when you talk about data points collected over time. They can either be stationary, or is there there could be seasonality. What you are looking at. So what I mean by seasonality is, just to give you a small example. Maybe if you take up the example for e-commerce data, so you can actually look at a bump in your sales whenever there's a huge big billion day sale happening, or any sort of things. Maybe you will, even if you talk about seasonality, even you can take up examples like maybe your woolen clothes sales go up, especially during the winter. Your AC sales go up, especially during the summer. So things like this. So is the target variable auto-correlated? Is it auto-correlated with all your other independent variables? Things like this. Now, coming to types of forecasting models, so here there are actually multiple types in which you can actually forecast your data. And here, it can be predominantly divided into two types of models depending on the type of data that you use. So one is the quantitative, the other one is the qualitative. So yesterday, when we were going through qualitative and quantitative data, so just to put it in layman words. So as you can remember, your quantitative are all your numbers, something that can be counted. The qualitative are all your categorical data. I mean, such as, like you said, maybe color of your hair, your nationality, and things like that. So now, the models that actually fall under your quantitative are, there's something called naive approach, your moving averages, exponential smoothing, projection. There, I would not get into too much technical in depth. So I'm just going to touch upon. I'm just going to touch upon these points, so you will actually know what they mean on a very high level. So when it comes to your naive approach, so here basically we wouldn't be doing anything. We'll just look at what has happened in the previous period, and we're just going to assume the same thing will happen in the future as well. So not much work required there. So when you talk about something called moving average, so here the way you predict your future or forecast your numbers are a little different. That is, you take up maybe if you're looking at data for 10 months, so your data for the fourth month, for the data for the fourth month, you will end up taking the average of your last 3 months. So, and this same procedure is continued for a rolling window as well. So, for your upcoming months as well, you take up the average of your last 3 months. And this can depend upon you. You can take the average of last 3 periods, or average of last 2 periods, average of last 4 periods. So now this again depends upon you. And after this, maybe you can actually look at the error percentage as well. So looking at your error percentage, especially when you are using moving averages technique, is very much important, because you will actually know where your data stands, where you stand, and what is the percentage of error that you need to incorporate, so that you can actually make accurate predictions here. Coming to exponential smoothing, this again is very similar to moving average, but the only difference is that here you will be using a weighted average approach instead of a normal average. So what happens in a normal average? I mean, even if you take mean or average on a very high level, so if you have 3 items, so you just sum up those 3 items and divide it by 3, 3 being the number of items in your data set. But when it comes to a weighted average, so what you do is you assign a default weight to all these numbers. So you take up their products, sum them up, and divide it by the total weights that you're taking. Basically, in a normal average, uh, all your weights are default. You just take one to be your weight, and if these weights vary, it means you are working on a weighted average approach. So exponential smoothing is a little robust and sophisticated when you talk about forecasting. Now, moving on, talking about trend projection. So here, what we do is we just look at the trend line for the past few periods, and then we decide that, okay, so since last year this was a trend, probably this year also we will be looking at the same kind of trend, things like that. Now, coming to qualitative forecasting models. So here, on a very high level, the type or the approaches that you have here is your executive opinion, your Delphi method, Salesforce estimates, and your consumer surveys. So coming to executive opinion and Delphi method and Salesforce estimates, I think all these are one and the same. It's just that you either have your leadership making a decision, or you have trusted advisors making a decision, or you find, if you look at your individual sales associates forecasting their numbers, so you take them as a reference as well. So it's either direct or indirect methods here. And now coming to your consumer surveys, I think this is pretty self-explanatory. So when you go out to a store, you look at people handing over those test kits to you. When even if you take perfumes to be an example or pickles, you would have seen this happening at over many places. So they give you a product to test, you test it out, and then if you like it, you go ahead and buy it. So think some, I mean, some these are just practical examples that I'm giving over to you. So now these were the types of forecasting models. I'll just go ahead. So this was about all your types of analytics. What is the again the division under your predictive analysis? That is, we spoke about our regression analysis, our time series forecasting. Um, so yes.